all to my channel Raj Education. Today I will be starting the first chapter of physics, that is chapter 1, the matter. So everybody get ready with the Selina Concise Physics book class 6 and open to page 3, chapter 1, the matter. Now what do you mean by matter? Objects or substances which take space and have mass are called matter. So anything or any substances which take space and have mass are called matters. Now this matter we can touch. We can touch the matter, touch the things. We can smell, we can sight, we can hear, we can taste. The things which we can smell, touch, sight, the things which we can see, smell, touch, hear and taste, all the things they are matter. And all the things of the universe, each and every things in the universe are made up of matter. So the word matter, it comprises of both the living and non-living things. So everything in the universe, even the sun, stars, earth, moon, human beings, plants, animals, insects, chair, table, galaxies, universe, these all are made up of matter. So you can understand what matter is used to indicate or used to describe all the living and non-living things of the universe. Now the matter, it can be divided into 3 states, into 3 forms. These forms are solid, liquid and gas. Now we will discuss about these 3 forms in details later. First we come to know about matter. What is matter? What is matter made up of? Then we will, what are the different types of molecules, or what are the features of the molecules. All these things we will learn one by one. So let's get started. Now in the ancient time, Indian philosophers, they used to believe that the matter or the things, that everything, it is made up of 5 elements, 5 things, and these 5 things are air, water, earth, sky and fire, means Panchtattvas. So the Indian philosophers, they mainly used to believe that the matter is made up of 5 elements or 5 substances, and these 5 substances are air, water, earth, sky and fire, means these 5 substances are together made up the Panchtattvas. Now Maharishi Kannada, he was an Indian philosopher. And he first suggested that all kinds of matter, all states of matter, solid, liquid and gas, they are made up of very much small particles known as Anu. And this Anu, they are again made up of very extremely small particles known as Paramanu. Now one Greek thinker named, the name of the Greek thinker was Democritus. He named or called the Paramanu as atom. He named the Paramanu as atom, and from that time it was concluded that the matter is made up of a very large number of extremely small substances or particles known as atoms. Even a small drop of water, even a single small drop of water can contain about hundreds of millions of atoms in it. Just imagine how small atoms are. And the atoms, they cannot exist freely, they cannot exist alone. They always live together, they always exist together, they never exist freely or alone. They used to live in a group. And when these atoms, they come closer, they form molecules. The size gets bigger when they joins each other. The sides are getting more and more bigger, and these bigger particles, the bigger particles of matter, is known as the molecules. An atom, it is the smallest unit of a substance. The smallest particles of the universe is the atom. There is not any particle that is smaller than atom. So the atom, it is the smallest particles from which the things are made. It is the smallest particle or the smallest substance in the universe is the atom. Now John Danton, he was an English chemist. John Danton was an English chemist, and he experimentally proved that the matter is made up of molecules. Matter is made up of extremely small particles known as molecules, and these molecules, they are again made up of very small particles known as atoms. So both these atoms and molecules together made up the matter. So the matter is made up of molecules, and the molecules is made up of atoms. And both these atoms as well as the molecules, they are so small that we cannot see with our naked eyes or with a simple microscope. We need to use an electron microscope to see these atoms and molecules, because they are extremely small particles. Now there are three kinds of molecules. There are mainly three types or three forms of molecules. These three types of molecules are monoatomic molecule, diatomic molecule, and polyatomic molecule. Now what do you mean by a monoatomic molecule? A molecule which consists of one atom. When the atom they did not join in this monoatomic molecule, the atom is itself a molecule. Some atoms did not join with other atoms. So the atoms which live alone or which live as a single atom is known as the monoatomic molecule. And in the case of monoatomic molecule, the atom is itself a molecule. And neon and argon, they are example of monoatomic molecules. And the molecules which consist of two atoms, when two atoms joins to form molecule, it is known as the diatomic molecule. Hydrogen molecule and oxygen molecule are example of diatomic molecule. And when more than two atoms join to form molecules, they are known as polyatomic molecule. Now example of polyatomic molecule are water molecule and ammonia molecule. Now characteristics of the particles of matter. The particles of matter are known as molecules. So the characteristic of molecules. So there are four main characteristics of the molecules. First one is the molecules are extremely small inside. Second, the molecules, they have some spaces or gapping between themselves. And third one is the molecules, they are not at rest. They are always moving in a zigzag manner, or they are moving in a random motion. And the fourth one is the particles of matter. The molecules, they always attract. One molecule is attracting another molecule. The molecules always attract each other. So the molecules are extremely small in size. The matter is made up of a very large number of extremely small particles called molecules, and these molecules are not visible to our eyes or to our naked eyes, or with a simple microscope also we cannot. Even with the normal or simple microscope, we cannot see these molecules. We need to use an electron or super microscope to see these molecules. So imagine how small are they. Now there is an experiment given. Now by this experiment we can prove that the molecules are very small in size. Now come to this experiment. first we have to take 100 ml of water in a container. Now with this 100 ml of water, we have to dissolve. We have to add two or three crystals of potassium permanganate in the 100 ml of water. Now after mixing it well or after stirring, we will get a deep purple colored solution. The color of the solution or the color of the water will be deep purple. Now from this 100 ml of water, from this 100 ml of solution, deep purple solution, we have to take 10 ml of water. We have to take 10 ml of this solution and we have to mix. We have to stir. We have to mix this 10 ml of solution with in the another vessel of 90 ml of water. In another vessel there is 90 ml of water. We are adding 10 ml from this 100 ml. So the second container is becoming 90 plus 10, 100 ml. Now we will see that this the color of this solution is not so much deep. The first solution was very much deep, was very deep purple. But when we are adding 10 ml of the solution to the 90 ml of water, we will see that the color is not deep pink, it is fainter, or the color has become lighter. It is not so as deep as the first solution. Now in this way we have to change. We have to keep we have to keep 90 ml of water and we have to mix it one by one. One by one we will take 10 ml and we will mix with the 90 ml. In this way we will do, and after at final we will see that one by one we are pouring, the color of the solution is also becoming fainter. One by one the color of the solution is becoming fainter, but the color is pink. It is not normal water color. The color is pink, the solution is pink, but it is not as deep as the first solution. It is pink but not so much pink as the first solution. Now this experiment prove or indicate that a single crystal of potassium permanganate is made or composed of a very large number of molecules which can change the color of a large volume of or large amount of water. Now the second characteristic features of the molecules is that the molecules, they have some spacing or gapping between themselves. The spaces of the gaps between the molecules among the molecules are known as intermolecular phase. So intermolecular space. So the space or the gapping between the molecules is known as the intermolecular space. Now here also an experiment is given to prove that the molecules have spaces between them, that is known as the intermolecular space. So first we have to take that 100 ml of water in a measuring cylinder. Now with this 100 ml of water we have to add 20 gram of salt and we have to stir. We have to mix the solution very well. Now after mixing the salt with the water, we will see that the level or the amount of water is not increasing. It is 100 ml. It is not 100. It is not the amount or the volume is not increasing. The water is same. The amount of the water is same. Even after adding the 20 gram of salt, the volume or the amount of the water is same. Why? Because the molecules of salt has occupied or has take the space between the molecules of water. So that's why the volume is not the volume has not increased. Now the third characteristic feature is that the molecules they are not at rest. They are always moving in a zigzag manner. They are always moving in a random motion. Now when sunlight comes in a darkened room, we can see the dust particles. We can see the dust particles moving in a zigzag manner. In the sunlight, we can see the dust particles moving in a zigzag manner. Why? Why these dust particles are moving? They are not at rest. Why they are moving? Because the air molecules are hitting. The air molecules are moving in random motion, and when these air molecules are moving, they are hitting or they are beating the dust molecules, and that's why both the dust molecules as well as the air molecules, they are moving in a zigzag manner, because the air molecules are hitting the dust particles. The air molecules are hitting the dust particles, and the dust particles, by getting hit from the air molecules, the dust particles, they are also moving like the air particles in a zigzag manner. Now when we spray a perfume, when a perfume is sprayed in one corner of the room, the smell of the perfume quickly spread throughout the room. If we spray in one corner, the smell quickly or randomly spread throughout the room. Why? Because of the motion of the molecules. Because of the motion of the molecules, the molecules of the perfume, they are quickly spreading throughout the room, so that the whole room is smelled with the perfume. Now the fourth characteristic features is that the particles of the molecules, they always attract each other. The molecules, they are always attractive. The one molecule is always attracting another molecule, and this attraction, this force of attraction between the molecules is known as the intermolecular force of attraction. And the intermolecular force of attraction helps in keeping the molecules together. Now we will see that some substances, some objects we can break into powder. Some objects we can break into powder. Some objects we can break into small pieces, and some objects is very difficult to break. So why we can changing some into powder, some into small pieces, and some is very much difficult to break. Why these are happening? Because of the intermolecular force of attraction. Because the intermolecular force of attraction varies from one type of substance to another type of substance. In one substance, when the intermolecular force in the substance is less, the substance, we can break the substance very easily. But when the intermolecular force of attraction is more between the molecules, it is very difficult to break the substance. So this because of the intermolecular force of attraction, we can change some objects into some objects into powder, some objects into small pieces, and some is very much difficult to break because the intermolecular force of attraction varies from one type of object to another type of object. Now here several examples are given to prove that the intermolecular force of attraction varies from one substance to another. It is very easy to move our hand. In water, but it is very difficult to move our hand in glycerin, because the force of attraction in glycerin is more and the force of attraction in water is less. So as the force of attraction in water is less, we can move our hand very easily, and in glycerin as the force of attraction is strong, it is very, we cannot move our hand easily. The second example is given that it is very easy to break a chalk into pieces, but it is very difficult to break a piece of coal because the intermolecular force in chalk is less and the intermolecular force in coal is much or more. So as the intermolecular force in the chalk is less, the chalk is very easy to break, and as the intermolecular force in coal is more, it is very difficult to break. And it is very easy to move our body in the air through the air, but it is very difficult to move our body through the water because the intermolecular force in water is more and the intermolecular force of attraction in air is less. So as the intermolecular force of air is less, intermolecular force of attraction of air molecules are less, it is very easy to move our body, and as the intermolecular force in water is more, it is very difficult to move our body. And if there is more intermolecular force, if the intermolecular force of attraction is more, then the intermolecular space is less, and if the intermolecular force of attraction is less, the intermolecular space is more. So the intermolecular force of attraction and the intermolecular space, they are linked to each other, because if the intermolecular force is high, then the intermolecular space is low, and if the intermolecular force is low, then the intermolecular space is high. So this intermolecular force and this intermolecular space, they are linked to each other. And in generally, mostly the intermolecular force of attraction in solid is more, in liquid it is less, and in gas it is least. So today I will not go further. I have explained up to the fourth characteristic of particles of matter. Next day I will be starting from page 6. Today I have completed up to page 5. So next day I will be starting from page 6. So please go through thoroughly through the portion which I have explained, and please like, share and subscribe my channel. So we will meet in my next video. Today after this, bye bye. We will meet in my next video.